Hello my dear students, look, I come back again with another important atomic property to understand chemical bonding. And today's topic is Ionic Radii and Covalent Radii. As we go in detail to understand the geometry and structure of compounds, we need to understand in what conditions they are, what are their sizes and what are their expected chemical behavior. So we begin with the concept. First, to understand the size of an ion, I must be very clear about what are ions and how they are formed. Ions are the charged bodies or species. And how they are formed? They are formed when electrons are exchanged. Means they may be added to any atom or they may be lost out. And whenever atoms gain electrons, it forms anions. Anions means the negatively charged ions. Means whenever any atom or group of atom gains electron, there is a net negative charge on it. But on the other hand, whenever atoms or group of atom lose electrons, it forms cations. Cations means the positively charged species. Okay, now we go ahead. If I'm talking about ionic radii, I must be giving some example of ionic compounds because ions are found in ionic compounds, and these two beautiful colorful pictures are explaining you a bit about their combination. Ionic compounds are oppositely charged ions tightly packed together in a fixed pattern, in a fixed lattice or unit. Means the colors are not only representing their combinations. You can also judge something. They may be of different sizes. Look at this example. The positively charged ion is much smaller as compared to the negative ion. Same is shown in this picture. So how are we gonna measure them? And this picture is helping you to understand the definition. That ionic radius is the distance between their nuclei. So the internuclear distance means the radius of the cation and the radius of the anion. More about them, how it happens or when it happens, what is the change. When we see the loss of electron happens, it results in the increase in nuclear attraction for the remaining electrons. Loss of electrons produces cations. As here, the lithium is losing one electron to make its cation, Li positive, but the size is decreased. From 152 picometer, the size is reduced to just 60 picometer. Same is the case of sodium, in which electron is lost and the size is reduced. How it happens? Because when atom loses one electron, one proton dominates, which results in the strongest force of attraction to the remaining electrons towards the nucleus, and the size is decreased. This is not the case when electron is gained. When electron is added or gained by any atom, its size increases because this time one more electron is added. Now take example of fluorine. When fluorine is ionized to fluoride, it gets a negative sign on it. And how it happens? It gains one more electrons. And this one more electron experiences electronic repulsion, which is called as shielding effect. And this repulsion creates a larger size. Same is the case for chlorine. The size increases from 99 picometer to 181 picometer. Now we understand that we are going to measure the internuclear distance in case of ionic compounds. But this is not the case when atoms are covalently bonded. Whenever atoms make a covalent bond, they do not exchange their electrons, but they only share those electrons. And we define it as the covalent radius of an element is defined as a half of the single bond length between two similar atoms covalently bonded in a molecule, such as the example of hydrogen. Now in this diagram, two identical atoms are covalently bonded, means they are sharing their electrons to complete their doublet. So we see the nucleus distance is divided into half. And you know what is the atomic radius of hydrogen? That is 208 picometer. So this is how we can tell about the sizes of atoms. Now to understand about their sizes and their trends, to predict the geometry and structure will become very easier. I am leaving you with the hope that you will be waiting for the next video. Till then, God bless you. Bye bye.